Our topic is absolute max or min and the mean value theorem. Enjoy the lesson. So our topic is absolute max and mins and the mean value theorem. We have three main objectives which we will be covering in our little mini lesson. The first is to determine the absolute max and min of a function, where the value is located and what the value actually is. Second, we are going to use the mean value theorem to find point C between A and B where the tangent line and secant line are parallel. And our third objective is to show that a function satisfies the mean value theorem on a given interval. So we have two main questions. Where will you have a max or min, which is the x value, and what is the max or min value, that is the y. That's very important to remember. Where you will have the max or min value as the x, and what that value actually is the y. So let's discuss places where absolute extreme values exist. 1, we have when the derivative is equal to 0. 2, the derivative is undefined. And 3, the endpoints. Where the derivative is equal to 0 and where the derivative is undefined, which you will see in our example, are the critical points. So the steps to find a max or a min value: find the critical points, which you find by setting the function equal to 0. Find the value of the function at the critical points. Then you want to make an xy chart with the endpoints and the critical points and their values. So our first example is y equals ln of x plus 1 on the interval of 0 to 3. The graph is shown below, and we will explain how to do it next. So the function is y equals ln x plus 1 on the interval of 0 to 3. You're going to start by finding your critical points by setting the function equal to 0. So we're going to add an e to both sides, and then we're going to have x plus 1 equals 1, and then we're going to subtract 1, so we have x equals 0. We're next going to make an xy chart, which includes our endpoints and our critical point. So our endpoint is also our critical point, so we're going to have 0 and 3. Then we're going to evaluate it by plugging it into the original function. So we have ln of 0 plus 1, which is 0, and we have ln of 3 plus 1, so it's the ln of 4. So ln of 4. So the max is at 3 with a value of ln of 4, and the min is at 0 with a value of 0. So this is the mean value theorem. If f of x is continuous over a to b and differentiable over a to b, then at some point c between a and b, f prime of x equals f of b minus f of a all over b minus a. So our example is f of x equals x squared plus 2x minus 1 on the interval of 0 to 1. The graph is shown below. So we are going to start by writing f prime of c equals f of b minus f of a all over b minus a. So f prime of c, we are going to find the derivative of our function. So we have 4, which we're going to replace the x with a c, 4c plus 2 equals, we're going to evaluate the function at f of b, so we're going to have 3, then we're going to evaluate it at, and we're going to have plus 1 when we evaluate it at a, all over 1 minus 0. So we are going to have 4c plus 2 equals 4, 4c equals 2, and c is going to equal 1/2. We hope you enjoyed the lesson.